In this problem, we're asked to solve an equation that has variables on both sides of the equation. So if you take a look, we've got 2/5 x on one side of the equation, right? And then we have a 3/10 x on the other side of the equation. And we also have constants. We have a 1/2 over here and a 7/4 over on this side. So what we're going to have to do is get all the variables to one side and all the constants to the other side. But like we talked about in the previous lecture, the first thing we want to do is clear our fractions, because that way it'll make our lives a lot easier. So we have to look for the least common denominator of all of these fractions, right? We have 2/5, we have a 5, we have a 2, we have a 4, and we have a 10. So again, if we're going to look at the least common denominator, that's the first number that all four of these numbers go into. We'll find that that number is 20. So what we need to do now is we need to multiply both sides of the equation, meaning every single one of these terms, by 20. And that way we'll get rid of the denominator and we'll have a nice equation again without any fractions. So let's go ahead and do that. So we have 2/5 x minus, and I'm going to leave a little bit of room here, 1/2 equals 7/4 plus 3/10 x. And like I said, I'm going to multiply every single one of these by 20 over 1. I'm not multiplying it by 20 over 20 because here I have an equal sign, so if I keep it balanced by doing the same thing on both sides of that equation. Right? So I'm multiplying it by 20 over 1, and that automatically gets rid of my denominators. So 5 goes into 5 one time, 5 goes into 20 4 times. 2 goes into 2 one time, 2 goes into 20 10 times. 4 goes into 4 one time, 4 goes into 25 times. 10 goes to 10 once, into 20 twice. So now I still have these terms here, which I have to simplify. Right, so my denominators all went to 1. Beautiful, right? So now I have 4 times 2 is 8x. Then I have a minus, and I have 10 times 1 is just 10. Equals, I still have my equals. Again, denominator is 1, I simply have 35. And plus 6x. Great, right? So now this is my new equation without any denominators. The next step is I want to use the addition and subtraction properties of equality, which means whatever I do to one side or add to the one side, I have to add to the other side. If I subtract something from one side, I have to subtract it from the other side. So let's see, I have an x term over on this side and I have another x term over here, so I want to get rid of those. I want to get rid of one of them on one side. So let's get rid of the 6x on the right side. So I'm going to subtract 6x, right, because I started off with a plus. And I'm going to put that down underneath the 8x because those are the same, they're like terms. So that makes my 6x's go away, and I simply have 8x's minus 6x's, and that's 2x. I still have my minus 10 equals 35. Eventually, when you get very comfortable with doing this, you can do a couple steps in one line. But for now, we'll keep it this way. Then I go ahead and I'm going to get rid of my 10. So I add 10 to both sides. Add 10 to both sides. My 10's go away. I'm adding 10 because in the original equation, right, I'm subtracting 10 there. So I want to do the opposite and I add it. So 10's go away and I have 2x equals 45. Now the last thing I do is either multiply or divide both sides to make sure that my coefficient of my variable is 1. And since I have 2 times x here, I'm going to do a division. I'm going to divide by 2. So my 2's cancel. and my x is simply 45 over 2. And that's my answer. So now if I want to check, let's go see if that works. Right? So my original equation was, let's see, we're going to check. My original equation was 2/5. I have 2/5 x minus 1/2 equals 7/4 plus 3/10 x. So here I'm going to plug in 2/5, and I'm going to take 45/2 for my x minus 1/2, and does it equal 7/4 plus 3/10 times 45/2? Right. So let's see, we'll work this part out first. My 2's cancel. 5 goes into 5 one time, 5 goes into 45 9 times. So I have 9 minus 1/2. And my question is, does it equal? Let's work on this side. I have 7/4. And let's see, 5 goes into 10 2 times. 5 goes into 45 9 times. So it's 7/4 plus 27/4. Okay, so let's see, I have 9 minus 1/2, that gives me 8.5, but let's see, we'll change this to 18 over 2 minus 1 over 2. Right, so that's 17 over 2. And here I have 34 over 4. And can that be reduced? Sure, that can be reduced by 2 and 17. So sure enough, I get 17/2 equals 17/2. So my answer is correct.